Unlike sequence, series are sums. Oh yeah, the sum notation comes back. So have some space, step away. A sub n is a sequence. 1, 2, 3, 4, 5, blah, blah, blah. Or cities, Tempe, Phoenix, Mesa, blah, blah, blah. What if we want to add them together? That's a sum. A sum from 1 to infinity. This is going to be called an infinite sum. Infinite sum. It doesn't have to be infinite. We will have finite sums as well, but infinite sums or infinite series are incredibly important. Infinite sum, infinite series. Sometimes notation will even ignore the counter. It will just says sum a sub n, and n is just some kind of stuff. Let's see the difference. Compare. So let's compare sequence versus series. Sequence versus series. Series. So a sub n is 1 over 2 to the n. That is the nth term. It will serve as an nth term to both sequence and series. Sequence, S-E-Q, looks like so. A sub n will be from, actually interesting to show you one more notation, 1 over 2 to the n. One more infinite notation looks like so. Since we only see one counter, which is not always the case, we can have several counters in the same time. Sometimes people put as from 0 to infinity, from 0 to infinity, without indicating which counter we're talking about. In computer science, you cannot do that. Computer will request you to indicate n is 0, I is 0, t is 0, what is 0 to infinity. But you will see it in the books, easier to type, and there's no other counters, so we assume we know what we're talking about. So who can tell me how this list will look like? What's the first term? What's the first term? How do you know? 2 to the 0 is 1, 1 over 1 is 1. Next term. Next. Next. 8. Next. 16. And that's how the pattern works. The nth term is 1 over 2 to the n. This makes sense. This is a list. As you can see, we are listing them. They're separated by commas. How about series? Series will be a sum of what? Well, let me write down. Sum of a sub n, which will be, check it out again, the same notation, from 0 to infinity. Sometimes people don't write the counter. So it's going to be the sum of 1 over 2 to the n from 0 to infinity. The difference will be now, instead of a list, we're actually adding those numbers. And we want to know how high this answer will go. How high means how large it's going to be. It is infinite sum. And this is the first time we are talking about infinite sums. And we will have to learn, do they converge? Do they diverge? What is happening here and why? One more definition is, even though it's an infinite sum, let me write it down, it is infinite sum. All of this. Some of it is finite. For example, this piece is a finite sum. Finite sum. So finite sums are part of the infinite sums. Kind of makes sense. Maybe you even think why we're discussing it if it's common sense. It's important from a mathematical point of view and calculations. So finite sums, or they're called partial sums. Partial sums, they are part of the infinite sum called S sub n. S infinity is the infinite sum. S sub n is a finite sum. So S sub 0 is the first term. 1 plus nothing. That's what we mean here. So there's nothing to add. That's why S sub 0. How about we add one term? 1 plus 1/2. You see, S sub 1 is the first sum. S sub 2 is 1 plus 1/2 plus 1/4. And as you can guess, it's keep going like so. S sub n will be 1 plus 1/2 plus 1/4 plus keep going plus 1 over 2 to the n. That is the notation for the partial sums. Partial sums. The finite nice notation for this n's sum can look like so. As always, the beginning of each chapter requires lots of definition, and after this we'll have lots of calculations, which are more fun actually. The sum of 1 over 2, let's not call it n anymore because we used n before for the previous notation, as you can see. That's how you know you have to switch the counter. For example, I or m or t. I told you usually we're using I, j, k, m, n. T usually is not used because it's for time. Computer scientists also use some others counters, and they totally messed up mathematical standards. Computer scientists completely messed up what we feel like very important. They just put it as a counter, and it kind of pisses everyone off. But that's just life. I is from 0, and now we stopped at n. So let me put it in highlighter. You see the difference? Now it's a stop moment. So we stop at n. We stopped at n's term. So those are partial sums, very interesting. Make a note like so, partial sums. And now very interesting, check it out. So not only, let me do like so. Partial sums, they look like so, s sub 0, s sub 1, s sub 2, go, s sub n. Does it remind you anything we just learned? It's a sequence. So partial sums of the infinite series, they create a sequence. A sequence is called s sub n goes from 0 to infinity. At some point it's keep going, I guess I should tell you. It doesn't stop. So it's keep going to infinity. And this is a geometric sequence. And that's why it's important. They have lots of theorems about it and why it's important. Let me write down, just for you to have good notes, and then later we're going to explain the formula of geometric sequence. Geometric sequence. So we're going to have geometric sequence and geometric series. Let's keep it as SEQ. Geometric sequence S sub n is written as sum 1 over 2 to the I go from 0 to n. Why is geometric sequence? Because as you can see how it was created. If you have a common factor, what is geometric sequence? When you have a common factor, that's by definition a geometric sequence. And then there are formulas for geometric sequence, which I will show you next time because I think it will confuse people. Every time somehow students get confused with geometric sequences. So I will show you next time that. But the main idea is to show that series are sums, unlike sequences or lists, and series have partial sums, and that's a sequence. So there's a connection between list of data and the sum of data. Why the sum of data is so important? The best example to mention is the COVID cases. When we count days, that's a counter, that's a sequence of days and how many patients we have in the hospital. When we add up together the numbers, that gives you the total number of patients being sick in a month. So sum gives you some output, the meaning, while the counter counts and collects data. And there are more other explanations, of course.